Now I'm gonna talk about my recommender, which is based on the K nearest neighbors collaborative filtering method. So here you can see inside the simple class 1Y program, there are local variables to be used to save all the data from the Excel file. And here's the main function. I can run it right now, which is basically do the test on the sample data to prove that my model is working. So the part 2 result is a generalized version for my part 1. So here I test all the possible k values and also give out the corresponding mean absolute error value for them. And I pick the best k, which is based on the lowest MAE value among them. So the best k is 12, and which will be used here in the part 3 to calculate the predicted ratings for all unrated items for both NU1 and NU2 as a target users. And here's the last part. I use my top N recommendation functions to help those users to calculate their top 3 recommended books based on the predicted ratings. So I'm gonna talk more about my codes here. So here the first function is a function to calculate the Pearson correlation function. Basically, it just take into uh, two rating lists for both the specific neighbors for the target user. For both target user and a specific neighbor for it, and calculate the specific neighbor's correlation or similarities with this target user. And here are two utility functions to support this correlation calculator. And then here comes to my KNN function, which is just like take into the previous outcome, which is a list for the Pearson correlation for all the possible neighbor inside the training data set and also the K sites. It will iterate through this list and also eliminate non-valid correlation and also resorting it, which is sorting it in the descending order based on the correlation values and record the top K or say nearest K neighbors with a target user based on their on the top highest k values correlations. So here is a rate predictor helper function, which is take inside the intermediate data and also the specific items which need to be rated. So inside this function, it just like iterates through all the nearest k data for the top k or nearest k neighbors and eliminate all the non-valid neighbors based on the rate and their correlation values, and also here finally calculate the final predictor rating, which is a weighted average. And here for each valid top k neighbor, their its similarity is actually become its weight. And here there is a default predictor which will be caught inside this helper function when none of the top k neighbors rated as a specific item. So, and here is another rate predictor function, which is take in more like official inputs. You can see the difference between this one and helper function, and it would just like do the previous work to analyze the data and also finally use the intermediate data, the nearest k data, to as an input and call the rate predictor helper function here and provide the same predicted rating for the specific item that it wants to rate. And here comes to the function to calculate the top end recommendation books for the target user. Here's the target user input and also define the top N and the K size. And for each target user input, it would just like identify the unrated books and also give out the corresponding predictor ratings and put them inside a list and sorting them in descending order, and finally record the top end books for these users and give that output as a recommendation. And the last one, the evaluation function, which is basically used to calculate the MAE value based on the input, which is a row index list for all the test users. So here it would just like iterate through this list to for each test user, it would just identify the rated items and give out the predicted ratings and compare two of them and also give out the absolute difference and sum them up and finally average all the test cases to give out the final MAE value as a arrow evaluation for the model. So that's it. I hope you enjoy. Bye.